Hello all, let's start our lecture. The first video is about 1.1, which our 1.1 covers 4 ways to represent a function. Correct? That's your 1.1 in your book. 1.1, 1.2, 1.3, they are reviews from your algebra course and pre-calculus, but still, because we have different students that they had classes with MSJC, or maybe they don't remember very well what is functions, what is a function, how to deal with these functions. Because in calculus, what we do in calculus 1, we deal a lot with the functions. It's really good to do a quick review. That's why you have it in first part of your book. I start with 1.1. Your 1.1 is 4 ways to represent a function, but even before explaining which ways we can represent a function, let's remind ourselves, what is a function? Let's find a solution first for this question, or an answer for this question. What is a function? I know many of you may remember the definition of a function, but if not, don't worry. I will give you the definition of a function here for you, and we will cover the main parts, right? Or the basics of a function. What is a function? In a one sentence, or in a very easy way to explain a function, what is a function? You can say function is a relation. This is a very basic, very simple, and even I can say incomplete definition for a function. Function is a relation. This word is really important. Function is a relation. Now, maybe you ask, what is relation? What does it mean, relation, in terms of math or mathematics, or in terms of algebra, or in terms of calculus? What is the relation? A relation for us in mathematics is an order pair. For example, when you write 1, 2, we call it an order pair. An order pair represents a relation. If you remember from your algebra course, when you write 1, 2 in a parentheses, it means when the value of x is 1, the value of y becomes 2, correct? If I put another order pair, for example, 2 and 4, it means when the value of x is 2, the value of y becomes what? 4, correct? That's why in a simple definition, we say function is a relation. But which kind of relation? That's really important. Can we say are all relations or functions? Is this a correct answer? Can all the relations be a function, represent a function? Or some of them, they just represent a function? To understand that, let's complete our definition. Let me start this way. A function is a relation, but which kind of a relation? That every single element in the domain has only and only one element in the range. If I draw here two sets for you, or a diagram here for you, two sets. Let's name this set X, let's name this set Y. Or you may more familiar with this table. When you graph a function, usually you use a table for linear functions, for quadratic functions. I'm sure you use a lot this table, right? This table and this diagram are the same, right? Let me put few values here. For example, 1, 2, 3. And let me put few elements in this set. For example, 5, 9, -7. Correct? When x is 1, your y is 5. When x is 2, your y is 9. When x is 3, y is 7. Correct? Or same way I can represent the same diagram here for you. 1, 2, 3, 5, 9, -7. When x is 1, y is 5. When x is 2, y is 9. When x is 3, y is 7. The values of set x, if you remember from your algebra, it's again a review. We call it input, or we call it domain. Your set x is your domain or your input. Set y is output, or we call it range. Correct? That's the meaning of the domain. When I use for the definition of a function, function is a relation. Which kind of relation? That every single value in the domain has only and only an element in the range, one element in the range or in Y. Let's explain it more. Let me draw this diagram for you. Another one. XY. This is your domain, this is range. For example, X1, X2, X3. I have here 4, 5, 6, maybe one more, 7. 1 goes to 7, at the same time 1 goes to 4. 2 goes to 5, and 3 goes to 6. Is this relation is also representing a function? I will say no, because it's not matching my definition. One element of the domain has relation with the 2 elements in the range, correct? That's why this diagram cannot represent a function. Maybe you remember in a graph, but later I'll explain it in a graph for you also, why you are not calling this one a function. Why you are calling this one, yes, it's a function. No, this one cannot represent a function. In a different way, if I use another diagram, usually my students, they like when I draw it this way. Let me draw a road for you. For example, there are 2 roads, and these roads merging to another one, to one road. There is a car going in this road, and there is another car going to this road, this way. Can both these cars can go at the same time to this road? The answer is yes. Remember, when you merge 2 freeway, the other cars are coming and you are merging to the same freeway and you go together with the other cars. It is possible. Now, if I draw this road this way, this is the car that your Professor Ahmed is driving. I'm sitting in this car. Suddenly, two roads are coming in front of me. Can I go at the same time to 2 different roads? It's impossible. No, I cannot drive at the same time to both of them. Oh, the only way is to send my tires here and send the body here, which is not possible, right? It's impossible. You cannot do this. This one, actually, this diagram represents this relation. One element of X, if I call this one X, cannot go to 2 Y's. But 2 different elements of X can go at the same time to 1 Y, right? Hopefully you remember back, I'm sure your professors in pre-calculus, even in Math 96, intermediate algebra, and also college algebra, because we are covering functions starting even Math 90, which we don't have it anymore in our college. We have Math 96, 105, and 110. We cover function is there, and I'm sure each one of you have a good understanding of a function. If not, that's the explanation that how I explained to you, correct? What is a function? Actually, this diagram is also a good diagram to understand what is a function. For example, this is a machine. This is your calculator, right? Think this machine is your calculator, the simple machine that I draw here for you. Think this is your calculator. For example, here I draw a square root. For example, you enter 4 to your machine, then you press the square root sign, and the screen shows for you too. Right? 4 is X. 4 is your domain. Or 4 is your input. This is the value that you put. 2 is Y, which we call it what? Range or output. This simple diagram can represent a function very well for you. What is domain? What is range? Or if I go to graph, your x-axis is the domain. The values of the x-axis is domain. The values of the y-axis, we call it what? Range. I saw this problem before. That's why I'm focusing too much. Because I saw this problem a lot with my students. Sometimes when I give them a graph and I see, okay, can you find the range and domain for me? They don't know how to read. They don't know what is domain, what is range. They don't know which axis shows the domain, which axis shows the range. You are now in your first level of calculus. I don't want to see that my students in a calculus class, they're struggling with the basic stuff of algebra, which is what is domain, what is range, because this book, we will talk a lot about the domain, range, function, the limit of the functions, the derivatives of the functions, the integrals, right? Whatever we discuss in this 4 months, in this semester, it's all about functions, right? Then it's good to review everything. That's why you have 1.1, 1.2 to 1.4 in your book. Now, if I do an example here for you, just a graph, let's take an example, X, for example, I draw a function like this. If I ask you to read the domain, how much is the domain of this function and how much is the range? What will be the answer? What is the domain? How much is the domain? How much is the range? Right? If I ask you to read the domain, please read the values of X from where your function starts, where your functions end, that's your domain. The domain of this function is from -2 to where? To 5. How much is the range? The lowest point in your graph, which is 3, to the highest point on your graph on the y-axis, which is 5. That's the range. You shouldn't have problem to read the domain or range of a function. Or another example, this parabola. If I ask you to read the domain and range of this function. For example, this is f of x equal x squared. This is the graph of this function, a parabola. What is the domain? How much is the domain? And what is the range of this function? It should become easy for you to read the domain and function. First, domain. You see these arrows? For every single point on the graph, you have a value of x, right? For every single point on your graph, you have values of x. On this side, on the negative side, on the positive side. And you have arrows in the end of the graph. It means this graph continues to where? Arrow means, do we know where this graph goes? This graph goes to infinity. Then what is the domain of this function? The domain of this function starts from negative infinity to positive infinity. What is the range? You see the lowest point on the graph is 0. And the highest point to infinity. I used here bracket and parentheses, and I'm hoping that you know the meaning of bracket and parentheses. Bracket means a closed circle. Parentheses means an open circle, right? It doesn't end. This notation, I'm sure everyone knows what is the meaning of bracket and the parentheses. Let me do another example in a different way. Let me give you a set of relations. For example, 2, 4, 5, 6, -1, and 4. Let's say 3 and 8. I will ask 3 questions here. First, is this relation a function? What will be the answer? Yes or no? Is this matching my definition? To check if they give you such a relation like this as a point, to check to understand if it's a function or not, check only the values of x. Correct? List them. List the values of x. You have 2, 5, -1, and 3. Check here. If you have repeating x that doesn't represent a function. If you don't have repeating x, you see x is not repeating. It's not the way you have 2 here and again 2. There is no repeating x. When there is no repeating x, then this relation represents a function. Hopefully you will get it. If I give you a relation like this, if someone gives you a relation like this, and they ask you, does this represent a function? The answer, just check the values of x. Don't worry about the values of y. If you have repeating y like this, you see here I have repeating y. It means 2 cars can go to the one road, right? It represents here, you see, your first car is 2, the other car is -1. 2 cars at the same time can go to one road, right? That's the illustration that I did for you. When you have repeating y, no problem. Later, when we discuss one-to-one functions, that definitely we will discuss one-to-one functions, then on that time, yes, it's important. But right now, to understand if it represents a function, yes or no, just check the values of x. Hopefully, right now, you should have a clear understanding of what is a function, what is a relation, what is the domain, what is range, how to find the domain and range of a function. Because we are discussing right now the domain and range of a function, it's good to do actually another example. I'll copy the example from your book. Example 2, sketch the graph and find the domain and range of the function. Example, they give you a function f of x equals 2x minus 1, and they're asking you here to find the domain and range of the function, and also sketch this function, correct? To sketch this function, you need a table. I don't want to discuss it. Everyone knows how to sketch a line, right? 2x minus 1, f of x equal to x minus 1 is a linear function, and it's really easy to sketch a linear function. Just actually you need 2 points, but to make sure, use 3 points, plug in an x, find the values of y, immediately you can graph your line, correct? When x is 1, if you plug in 1 here, 2 times 1 gives you 2, 2 minus 1 gives you 1. When x is 2, if you plug 2, 2 times 2 gives you 4, 4 minus 1 gives you 3. If you plug 3, 2 times 3 gives you 6, 6 minus 1 gives you 5. And if I want to graph now this line, it's really easy to graph, right? This is x, this is y. When x is 1, y is 1. It means this point. When x is 2, y is 3. 2, 3. This point. When x is 3, y is 5, or 5 somewhere here. And if I connect these 3 lines, which my graph is always not good, I'm really bad in drawing, correct? It represents your, this line represents f of x equal to x minus 1. This is the graph of f of x equals to x minus 1. Graphing is not our concern in this problem. Our concern is what is the domain of this graph and what is the range of this graph. You see on the 2 sides of the graph, I put arrows. If I change the color for you, for every single value of x, you have a value of y, you see? When x is 1, y is 1. When x is 2, y is, for example, 3. When x is 3, y is 5, right? And it continues this way. For every single point on the graph, the values of x is going this way. And also on this side. For every single point on the graph, you have a value of x. Then the domain of this function is from negative infinity to where? To positive infinity. And the range, again, you see for every single value of y, for every single value of x, you have a value of y. You see, your y is going to negative infinity and this side to positive infinity. Then the range is also from negative infinity to positive infinity. Correct? This is how you read the domain and range. Later, even without graphing, I will explain for you how to find the domain and range of a given function, even without graphing, right? Few things. Now I'll go back to black color. Linear functions, quadratic functions, and other functions that they are higher degree polynomial functions, which we call them in general polynomial functions, correct? To find the domain and range of polynomial functions, it's really easy. How to know the domain and range of a polynomial function? First, polynomial functions, which covers also your linear function. The domain of polynomial functions start from negative infinity to positive infinity for all of them. Even you don't need to draw a table. Even you don't need to think about what is the domain of this function. The domain for all polynomial function starts from negative infinity to where? To positive infinity, correct? For example, the domain of a linear function, for example, f of x equals 3x plus 1, the domain of quadratic functions. For example, f of x equal x squared plus 2. Cube functions, f of x equals x cubed minus 4x squared plus x plus 1, for example. Or in general, polynomial higher degrees than 3, right? We call these functions polynomial functions. The domain of all of them starts from negative infinity to where? To positive infinity. There are other types of the functions that later we will discuss. Their domain has some restriction that you already studied in algebra, but I'll do another review for you, right? Later, I'll explain the domain of those types of the functions too. For example, I'll leave it for 1.2. I'll explain those. When I introduce those functions for you, I'll explain also how to find their domain in section 1.2. Now, the next topic and 1.1 is if someone gives you a graph. For example, let's do our curve, our quadratic. How I should know if this curve represents a function. Here, I discuss with you that if I give you an ordered pair, if I give you a set of ordered pair or relations, if I ask you if it's a function or not, just check the value of x. If there is no repeating x, it represents a function. But here, what? If I give you a graph, how you should know that this graph representing a function or not? What you do here to understand if a graph represents a function or not, you should do a vertical line test. Remember from algebra? I'm just repeating those for you. The test is, we call it the vertical line test. What does it mean? It means draw a vertical line in different parts of your graph and check if your vertical line intersect the graph only once, only and only once, that graph represents a function. You see, I draw a line here, it only intersects once. I draw another line in this part of the graph, only intersects one. That's why I call this function as a function. This graph is representing a function. Let me draw another graph for you. Like this. This is x, this is y. If you draw a vertical line here, you see your vertical line intersects the graph more than one time, correct? At least here 2 times. Then this graph does not representing a function. It's not a function, correct? We call this process a vertical line test. It was a review, that's why I'm a little bit fast, because everything that I'm discussing today for you, it's a review, correct? After you learn what is domain, what is range, what is a function, how to graph a function, how to know if a graph represents a function or not, the next topic that you should focus on is evaluating a function. I'm sure in some parts of your book, they don't put these topics in every single section because they know that you already studied these stuff. That's why maybe you cannot see a topic in your book, but I'm kind of explaining here one by one, evaluating a function. What does it mean? Or evaluating functions, correct? What does it mean? Evaluating a function means finding the numerical value of a function, correct? That's what we call it, evaluating a function. Again, I saw students has a lot of problems, especially when they start with intermediate algebra. I'm sure no one has this problem in your level, and they don't know. When I give them a function and I say evaluate, they're thinking now what to do. Evaluate means finding the value of the function in the given point, correct? For example, if I give you a function f of x equals, let's take a very easy example, 3x minus 1. And if I ask you find f of 2, the process that you are looking for the f of 2, we call that process evaluating a function. It means when your x is 2, how much is the value of y? This process is difficult for some students. I don't know why. I'm trying to find the reason. But you see, say, okay, now how to find the f of 2? Look here. A function is given to you. F of x equals whatever variable you have here, f of x. You see the same variable on the other side. I cannot write this function like this. F of x equals 3y minus 1. If I write even, it's not the right way of writing. I have x on this side, I have x on this side, correct? F of x equals 3x minus 1. Find f of 2. It means wherever in your function that you have x, you have to replace it with what? With 2. To find f of 2, then f of 2 equals 3 times 2 minus 1, which gives me 6 minus 1, which is 5. We call this process evaluating a function. That was a very simple example that I did. Now I copy another example from your book. For example, they give you f of x equals 1 minus x if x is less than equal negative 1 and f of x equals x squared if x is greater than negative 1. It's not a face-to-face class. Unfortunately, I cannot ask you a lot of questions. One of my maybe good habits or bad habits is that when I have a face-to-face class, I ask a lot of questions from students. And the reason of asking questions from the students is always not to show that they don't understand something. No, no, no. My goal is not that. My goal is that I want to work always together with my students. But right now, I'm just recording my lecture. Even if I ask a question, it's kind of useless. These types of the functions that you see here, we call these functions piecewise defined functions that you studied in college algebra and pre-calculus and also intermediate algebra. We call these types of functions f of x equals 1 minus x, f of x equals x squared. We call these functions piecewise defined functions. Now, they are asking you in this problem to find, for example, f of negative 2. The problem is, or the mistake comes from where? Where I should plug negative 2. In this function, 1 minus x, or in the second function, which is x squared. Actually, piecewise defined functions, they represent many functions. Here, actually, you are dealing with two functions. The first function is f of x equal 1 minus x. The second function is f of x equal x squared. This is the meaning of piecewise. Now, f of 2, where I can find f of 2? In the first function or in the second function? To avoid mistake, where to plug this to and which function, always look for the restriction. Actually, this part is the domain, representing the domain of your function, correct? You see, if the point that they're asking you to find the value in that point, if that point is in the domain or not. Look for the first function, which is f of x equals 1 minus x. The domain is x less than equal -1. It means that my domain is the domain starts from -infinity to -1. That's the meaning of x less than equal to the -1, correct? That's your domain. Now check, is -2 is in this set? If you see the number line, here you have -1, here is -2, and you go to -infinity. You see -2 is in the domain of this function. Then you can plug -2 to this function and you can evaluate your function. But before that, check the other function also. Is -2 is in the domain of the second function, f of x equals x squared. What's the domain? It gives you the domain x greater than -1. Correct? It means from -1 to infinity, right? Greater than -1. S2 is here, -2 is here. No. Then don't plug -2 in the second function. To evaluate f of -2, I will copy my first function, f of x equals 1 minus x, I think. What was 1 minus x? Because -2 is in my domain, then it's easy to find the f of -2. f of -2 equals 1 minus -2. Double negative becomes positive. 3. Then f of -2 is 3. You cannot plug -2 in the second function. They give you another value also. Evaluate f of -1. To evaluate f of -1, can I plug in -1 in my first function? Check the domain. What was the domain of the first function? From -infinity to -1. Yes, I can plug it in my first function. Can I plug -1 in the second function? What was the domain? The domain was from -1 to infinity. Can I plug it? What is the difference? Here, I will say, yes, I can plug it. Here in the second function, I will say, no, I cannot plug. Because you see here, I have a parentheses. Parentheses means that -1 is not in the domain. But here you have bracket. Bracket means -1 is in your domain. You see here less than equal. And here you have only greater. Correct? Then plug -1 in your first function and you can find the value of f of -1. I'm not going to finish this example. It's in your book, and also this example is in the PowerPoints or presentations that that you have in your Canvas. You can go and see it and you can plug and practice it, correct? The next topic that we want to cover in 1.1 is symmetry. What is symmetry? We use symmetry a lot to make our life easy to graph a function. or to find some information that we need about a function. For example, if I have a function, for example, f of x equal x squared, this is the only easy function that I know. I know the shape of this function is a parabola, correct? Two sides of this function are symmetric about y-axis. This function is symmetric about y-axis, correct? Now, based on this symmetry, we have two types of the function, of functions. First, even functions. Which kind of functions? We call them even functions. A function, if I give you a function, for example, f of x, if you look for the f of negative x, correct? If you look for the f of negative x, and the f of negative x becomes the same as f of x, we call those types of the functions even functions. Or in an easier language, every time that I give you a function, for example, f of x equal to x squared plus 4, if I ask you it's an even function or odd, what you do, replace your x with negative x. This is the test. Remember, to check a function is even or odd, always replace your x with negative x. Here, look for the f of, let me change the color, negative x. Correct? I'll do this. 2 times, I'll replace my x with negative x squared plus 4. Why I'm doing this? When you replace your f of x with f of negative x, f of negative x becomes equal to the f of x. You call your function even. And after doing this test, if f of negative x becomes equal negative f of x, we call these functions odd functions. Correct? For example, in here, you see I replaced my x with negative x. Let me work on this. 2 negative x squared gives me back positive x squared plus 4. You see that here on this side, you have f of negative x. Your f of negative x, which is this, look at the right side, and look at the right side here. F of x equals to x squared plus 4. F of negative x equals to x squared plus 4. The right side is equal. It means your f of negative x becomes equal to f of x. Then this function is an even function. Let me take an example of odd functions. Let's do the easy one. F of x equal x cubed. To test if this function is even or odd, I'll replace x with f of negative x. Then this one will be negative x cubed. And you know a negative number to the power of odd gives you back negative. That means f of x, f of negative x equals negative x cubed. You see, your f of negative x equals the negative f of x. They are the same. Only thing that there is a difference is this negative, right? then I say this function is odd. Then remember, every time that someone is asking you, or I'll ask you, is this function is even or odd? What should you do? Replace your x with negative x. F of negative x becomes equal f of x. The function is even. If f of negative x becomes equal negative f of x, on that case, your function is odd, correct? I'm sure you remember these lectures, but still I want to explain a lot for you, correct? Let's do now another example from your book. F of x, what they're asking in this, determine whether each of the following functions is even, odd, or neither. F of x equals x cubed, or x to the power of 5 plus x. They're asking you to check if this given function is even or odd or maybe neither. Correct? To check, I look for the f of negative x. It means I replace in my functions x with negative x. Then this one becomes negative x to the power of 5 plus negative x. F of negative x equals negative x to the power of 5 gives you negative x to the power of 5. Positive times negative gives you another negative, minus x. Look, if here both of them is negative, if I take negative, if I want to take negative as a common or factor negative, it becomes like this. F of negative x equals negative x to the power of 5 plus x. I took just negative as a common. Check. This was your f of x. This is the same as f of x, but you have a negative outside. It means your f of negative x equals to the negative f of x. It means your function is what? Your function is odd. Correct? Hope this example could explain everything to you. Next topic in 1.1 is how to know a function is increasing in a given interval or decreasing in a given interval. It's a kind of subtopic here. Increasing and decreasing functions. Even I'm not happy with this title. They should say in which interval a function is increased and in which interval a function decrease, correct? But they put a general name here, increasing and decreasing functions, correct? How I should know if a function is increasing in a given interval or if a function is decreasing in a given interval. To understand that, let me use a simple graph here and I'll explain to you how you can understand in which interval the function is increasing and which interval a function is decreasing. Let me graph such a thing. For example, this. Right? Let's consider this graph. Let me use a closed interval. To explain it to you in this graph, if I consider the left side of this graph, correct? If I name this point x1, definitely the value on the y, I can call it f of x1, right? Or y1. If I name this point, which is on the y-axis. Let me take another point, maybe here. If I name this point x2, then the value on this, on the y, will be f of x2. Now, you see your x1 is less than x2. Are you agree? X1 is less than x2 because I'm on the negative side, right? X1 is smaller than x2. When you are closer to 0, that number is bigger, right? As you go far from 0, the number gets smaller and it's smaller. But what about the relation between f of x1 and f of x2? Clearly, you can see that your f of x1 is actually smaller than f of x2. If you end up with such a relation that your x1 is less than x2 and f of x1 is less than f of x2 in a given interval, usually they call it interval I, we name. Interval I means from here to here, right? In the given interval, you call, in this case, the function is increasing. Increasing, right? How to know a function is increasing? Always check if x1 is less than x2. The f of x1 should be less than f of x2. In that interval, the function is increasing. Now, how to know the function is decreasing? Let me change the color of my pen. For example, let's check this interval in a red. This one is x1. This point is x2. Definitely your x1 is less than x2. But look here, this is your f of x2 and this is your f of x1. You can see easily that f of x1 is actually greater than f of x2. If you see such a relation that x1 is less than x2 and f of x1 is greater than f of x2, in this case, the function is decreasing in the given interval, right? Your function is decreasing. It's really easy for you to understand when a function is increasing, when a function is decreasing. The best way of explaining is on page 19. There is a blue box there, and you see these two stuff there. Actually, I copied and paste. That's the same way of explanation, right? It's easy for you to understand in which interval a function is increasing and a function is decreasing. That's the way to check, correct? Which interval is increasing and which interval is the decreasing. That was all about 1.1. I will stop my lecture here. In the next video, I'll explain 1.2 for you, which is mainly our focus is on the types of the functions. We introduced to you like at least few types of the functions, and then that will be a short lecture. Then we jump to 1.3, which is in 1.3 we will cover for, I will cover for you new function from an old function. That's a kind of thing that we have to discuss, but 1.2 is easy. Please, 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 if you have problem with understanding of a function, I'm encouraging you to, you have a chance this semester because I record the lectures and I post it on your Canvas. Watch the lecture a few times. If you are in a face-to-face class, you have only a chance to watch a lecture or listen to a lecture once, right? But in this online method, actually you have chances to watch a video as much as you want. Just watch the video, read your book, read the slides, do your homework. I'm sure everyone will have a good grade at the end of the semester. Not only good grade, a very good understanding of Calculus 1. I'll stop the lecture here and see you next time for 1.2.